Hi, I'm Susan Swarner. I'm from the Westchester Township History Museum, and today we're going to be celebrating National Fossil Day. National Fossil Day is October 14th this year, and we're going to celebrate it by learning about some fossils and how they're formed. So let's get started. So what is a fossil? A fossil is preserved evidence of ancient life, so ancient plants and animals that lived on our planet a long, long time ago. There are kind of two main categories of fossils. There's body fossils, and these are any fossils that are going to show us what the animal actually looked like. So things like bones, things like teeth, things like maybe hair even, or feathers, or leaves that got preserved. The other kind is trace fossils, and these are just showing us how the animal behaved or their kinds of activities. So these are going to be things like fossilized footprints, something called trackaways, which are kind of showing how animals move through an area, so maybe a whole bunch of footprints in one spot. Things like nests are a big trace fossil. Bite marks on bones, so you can kind of see how animals ate. And then one more called a coprolite, which is actually fossilized poop. And that can give us a whole lot of evidence about what an animal ate. Now I'm going to show you how fossils are formed as best I can without 350 million years on my hands. So, first thing we need to do is we need to get some dirt. And you can try this at home if you want. Just make sure before you dig in your yard, you tell someone and ask permission so that they know there's going to be holes out there that you dug. So we're going to dig up some dirt, and then we're going to put it in a container and mix it with water, because we want to create kind of a clay, like a mud that we can use. So I'm going to add a little bit more dirt to this. All right, so this is the mud we're going to use when we create our fossils. So we're going to go do that next. All right, now we're ready to create some fossils. So the first step is we have to have a layer of earth that these animals can live on. So I'm going to take some of the mud. It's okay if there's roots in it. And this is just a takeout container I'm reusing. Any kind of container will work that has a flat bottom on it. We're going to create a layer of dirt. All right, so now we have the surface of the earth. So now our animals are going to come in, and what happens with fossils is, first off, the animal dies. And then, so there's our dinosaur. Here is a shell, kind of represents like a brachiopod maybe. These are just going to represent other animals or plants that have died on the surface. Then what happens next is all the soft parts of the animal, like the muscles and everything, those decompose. And we talked about decomposition this summer, right, in those videos. So those decompose, they go back into the soil, back into the earth, leaving just the bones behind. And then what happens pretty quickly before anything happens to those bones, whether they break apart or decompose, more sediment comes in. So sediment is just like mud or sand, any kind of dirt. And it's going to create a layer over those animals, over the bones. And then that keeps happening. So we have a layer of sediment. We have another layer of a different kind of sediment that comes in. And these layers just keep building up and building up. And as these layers build up, they start to press down on each other. They get pretty heavy. And that pressure is so strong that eventually they become something called sedimentary rock. They harden so much they become rock. And that rock, sedimentary rock, is just rock that is made up of different layers of sediment. So different layers of mud or dirt, sand, anything like that. Clay. We have another layer here. And again, that pressure of all these layers building on top of each other presses down on the other layers of sediment to create stone. It also presses down on the bones. And then what happens after it turns to stone? Something called groundwater, so water that trickles down through the soil, not water from a river or an ocean, but water that trickles down through the ground, through this rock, eventually gets to those bones that are buried deep under here. And what happens is the water has something called minerals in it. Minerals are like tiny, tiny rocks that you can't even see in the water. And the water trickles through the bones and the minerals get left behind. So eventually those bones get replaced by minerals, but the minerals form an exact copy of those bones. So that's what creates those fossils. The fossils you see in museums of dinosaurs or mastodons, those are mostly minerals that have taken the shape of the bones of those animals. And then what we're gonna do is we're gonna let this dry for a few days. This takes a while to dry, like 3 to 5 days. And then we're gonna come back and I'm gonna show you how those fossils get discovered. So I have let our fossil demonstration dry for 5 days. I gave time for the mud to solidify. It's still not completely dry, but it's good enough. And now we have to extract these fossils. So in the real world, what would happen is something called erosion would expose the fossils, or at least a part of them. So we talked about erosion this summer in the soils video. It's just when rain, wind, other sources of water run over an area and erode the soil, the dirt down to the point where a piece of that fossil is going to stick out. And this is a really common way fossils are found outside, is when the dirt gets washed away and they get uncovered. So these layers of sediment that have been pressing down on those bones and turning them to fossils start to get washed away. And we're going to very carefully extract the fossils from this soil. The scientists that do this have to try to get the fossils out and as carefully as possible so that they stay in their shape so we can get as much information for them as possible. So that's what we're going to do next. So let's start extracting from fossils. You can leave yours like this if you want. Or if you have a container that you're able to kind of press it out of, you can do that too. I would advise doing this part outside if you can, or maybe lay some newspapers down on the table so you don't get it too messy. So here's our little dig pit. You can see the layers of sediment, layers of sedimentary rock that have been created. So now we have to extract these fossils as carefully as possible. The kind of scientist that extracts fossils like this, that studies ancient life like this, is called a paleontologist. So paleontologists just study ancient life. So their goal is to extract the fossil as carefully as possible because the more intact, the more whole the fossil is, the more information we can get from it. So they use really small tools to do that. You're not coming in here with a bulldozer or anything like that because you don't want to break those fossils. So they might come in with a shovel. The shovel's obviously not to scale. It's a little big for this. They're just going to gently start digging away that sedimentary rock in the dirt. And then they might come in with kind of a smaller tool to dig dirt away. Look, we've already got our first fossil uncovered here. And they're just trying to get it out as carefully as possible. And if we're really careful, we might be able to get something called an impression. You can also come in with some brushes. Here's our fossil here. If we're really careful, we would not only will have this, which is kind of a cast of a fossil. So this would be the minerals that filled in that space. We would also have the molds. We don't have too much of a mold here, but the mold would just be the impression left by the fossil. So the result of the bone being pressed in. When you remove the fossil that's formed, you're going to have an impression of it in the dirt. So those are two kinds of fossils we could have. So let's be a little more careful and see if we can get an impression of a fossil. Takes a long time to dig fossils out. It's not a quick process. All right, so here's that shell. Let's see if we can take this out carefully enough to get one of those impressions, a mold fossil. So we're going to get all this dirt out of the way. A big chunk of it there. You can use any kind of tools you have at home for this. If you have like a toothbrush or a butter knife. I have all these kind of clay tools and paintbrushes, but you don't have to have stuff like that. You can use whatever tools you have at home. All right, still not quite coming out. Loosen enough to at least get a partial impression fossil. Alright, so it's not perfect. We have a little bit of impression, a little bit of that shell line you can see here to create that impression fossil. And then this would be the fossil that formed out of minerals. So now you have an idea of what paleontologists have to do to dig up these fossils. It's a really long, slow process. It takes a long time to dig a fossil out of the ground, especially since the ground they're digging out of is even harder than this ground normally. So it just takes a while. But if you do it really slowly and really carefully, like the scientists, like the paleontologists do, then you're gonna get a really intact fossil that you can get a lot of information from. And that's really, really important for us to be able to study ancient life. A lot of times when paleontologists are searching for fossils, they're searching places that are far away from Indiana, like out west, like Utah or Nevada or Montana, or even all the way over in Europe and Asia. But you don't have to go that far to find fossils. We have a lot of fossils that you can find right here in Indiana. So about 350 million years ago, a long, long time ago, Indiana was covered in a saltwater sea. So we wouldn't be standing here right now, we'd be standing in water. And a lot of animals lived in that sea. And when they would die, they would sink to the bottom and they would get covered up with minerals and sediment, just like in that demonstration we did with our little dig pit. Eventually that sediment would settle, turn those animals into fossils, and they also turned the rock into a sedimentary rock called limestone. We have a ton of limestone in Indiana, especially southern Indiana. That limestone is full of fossils. Today we use that limestone to build buildings, but also to create gravel driveways. We crunch it up and cover our driveways with it. So gravel driveways are a great place to look for fossils right here in Indiana, right in your own backyard. When you're doing this, make sure you tell a parent or a trusted adult that you're out in the driveway looking. You want to make sure people know you're there so you're safe. But it's a really great place you can find fossils right in your own backyard. So these are some fossils I found in my gravel driveway over the course of the whole summer. So I did not find these all at once. You might only find one, you might find none when you first start looking for them, but it is a great place to easily look for fossils. So these are just some examples of ones I found. This kind of shell looking fossil here, that would be the mold, the impression of the fossil. This one, this is probably a brachiopod, but you can kind of see that shell shape there. So these are all animals that would have lived in that sea 350 million years ago. Think about how old this gravel is, how old these fossils in the gravel are. I don't know what all of these are, but that's okay. There's guidebooks you can look up at the library, you can look online for resources. You don't necessarily have to know every kind of fossil you find to know that it's pretty cool to find something that's 350 million years old. A really common thing to look for, brachiopods are really easy fossil to find in gravel. You're just gonna look for these lines and you're gonna want them to be repeated over and over again. If they're just one single line, might not be a fossil. But if you see something that really looks like that back of that shell, probably a fossil of a brachiopod or some other kind of shelled creature from that sea 350 million years ago. So you can even find really tiny pieces. And part of this is just practice. As you look more and more, you're gonna get used to looking for those patterns in the rock. And that's gonna make it a lot easier to find fossils in your driveway. But again, these are all ones I just found walking up and down my driveway over the summer. So if we want, we can go look around and look in the driveway now and see if we can find any new ones today. So the key to finding fossils in your driveway is just be really patient and just really look at the rocks and look for those patterns we saw in those ones I found earlier. If you wanna practice looking at what the fossil is supposed to look like, you can look in guidebooks you get from the library, you can look at pictures online. Those are all going to help you kind of train your eyes to look for those specific patterns that a fossil would look like on the ground. But again, just walking around, looking really closely at the gravel, you're probably going to find some kind of fossil, even if it's just a little part of one, like some of the ones I showed you. So just looking really closely. So like here's some evidence of a fossil here. I don't know what this is, but you can see that pattern on there. That's not just from the rock being eroded or hit up against something. That's a pattern of some kind of animal or plant that would have lived in that ocean 350 million years ago. So what I could do is I could try to go online or take a guidebook and figure out what kind of thing this is. But for now, it's just kind of cool to know that I found it. So here is one more I found just now. This is another mold, so you can see the impression of that shell that was pressed into the limestone. What's cool about this one is if you see that sparkle, that's showing you the minerals that are in here that replaced the shell that was originally buried by this sediment. All those sparkling things are the minerals that are in the rock. So now I'm going to show you how you can make a little fossil for yourself at home. So this is going to be similar to the fossilization process I explained earlier. Obviously not quite the same because we don't have millions of years to wait around for your fossil to form. But what you're going to do is you're going to take some Play-Doh, or really any kind of clay. So if you have modeling clay, if you have air dry clay, you can even use the mud that we made earlier. You're gonna spread that down. If you're using the mud, make sure you let it dry after. I'll show you what step to let it dry for. So you're gonna spread that in the bottom, any kind of container. I'm reusing this plastic takeout container because I don't think it's recyclable, so find another use for it. All right, so you're gonna get a layer of Play-Doh. And then what you're gonna do is find some things you wanna make fossils of. So you can use leaves. Leaves work really well for this. Use the more textured side, the side that has a lot more sticking up. You're just gonna press that into the Play-Doh. And then I'm gonna use the shell. I think that'll create a cool pattern. I'm gonna press that down. You don't wanna make these too deep. All right, so there's my shell pattern. And then I have this little toy dinosaur. Do a little impression of him. All right, peel this leaf up really carefully. Oops, ripped it a little bit, that's okay. So now I have 3 impressions in here, sort of 3 mold fossils, right? Just the indentations of where the stuff used to be. And then what you're gonna do is take some glue, any kind of school glue, and you're gonna fill those spots with the glue. It's okay if you go a little bit outside the lines. Shell fossil, and I'll do the leaf. So now these are becoming our cast fossils. So this glue is kind of like those minerals that are seeping in from the groundwater and replacing what was there before, replacing the animal or plant. All right, so now what we have to do is we have to let this dry for a while. You want to let it dry for at least 24 hours, but if it's not completely dried by then, let it sit for a couple days. And then when it's completely dry, I'll show you what we do next. Here is our second little fossil demo. So now I'm going to show you how to peel these out so you can have fossils at home. So if you can pull this out if that makes it easier, or you can leave it in the container. I'll pull it out just because it's already out. So now we have to really carefully pull this glue out. I let this dry for 5 days. You can let it dry longer. If it gets done sooner than that, you can pull it out sooner. But make sure it's completely dry. Now we're just gonna really carefully pull this glue out, and we're gonna have the mold, the impression of the fossil left in the Play-Doh, and then we'll have the cast, which is gonna be the 3-dimensional fossil that we're gonna have in the glue. So I'll start with the dinosaur. I think that's gonna be the hardest one to peel out. See how it goes. Oh, no, this is the leaf. Very cool. So you can see, and we have that leaf fossil now. So you can see the lines in it. You can also see the lines in the impression still. So at home, you can grab a pair of scissors and cut these two apart. I'll just keep peeling. I believe the next one was a dinosaur. So again, really slowly peel it out. This one's gonna be a little trickier because we got those deep legs that are pressed in. Again, just go really slow. Cool. All right, so now we have the impression down here of the dinosaur. We also have the fossil of our dinosaur here. You can see all that texture. So this glue kind of represents those minerals that replace the bone and create that fossil. So this is what you'd see in the museum. They also might have the impression fossil if they were able to remove it from the ground. There's 2 of our fossils. Let's get our last one. Let's get this shell out here. Again, just really carefully peel it up. There we go. There's our last fossil. See the impression here, the mold, and then we have the cast fossil that filled in that space. So now you have 3 fossils at home. You can rinse these off if you want to get that Play-Doh off, or you can let the Play-Doh dry and scrape it off later. But now you have fossils at home that you can keep. You can even keep these if you want to let this dry and keep it around. Now that we've talked about what a fossil is and how they formed, and we've seen some fossils we can find in our own driveways, I'm going to show you some of the fossils we have here at the museum. A big reason fossils are important is because they're the only way we're able to study all the ancient life that used to live on our planet that isn't here anymore. So finding fossils and looking at them in places where you do research or places like a museum can tell us a lot about our history of our area. So that's why fossils are really important in terms of studying how life used to be. So I'm going to show you some of the fossils we have in our collection so you can see what we have here. And these are all things that were found in Indiana and animals that used to be living in this area a long, long time ago. So before we get into our real fossils over here, I'm going to show you this one. This is a reproduction, meaning it's not a real fossil, but it is made from a mold of a real fossil. So this is the same size and shape that this animal's fossil would be if you found it in the ground, but it's made out of plaster. This is a saber-toothed cat. So this was an animal that was here during the Ice Age. And it looks like a big cat, or like a big bobcat. It had these long teeth. And it did live in Indiana. They actually found a saber-toothed cat fossil down in Monroe County, Indiana, which is in southern Indiana. So these animals did exist here during the Ice Age. The first fossil we're going to talk about is the crinoid. And you might have even seen a crinoid fossil if you ever go up to the beach on Lake Michigan and look along the rocks on the shore. This is an ancient animal back from when Indiana used to be covered by a shallow saltwater sea. And while it looks like a plant, and some people call it the sea lily, it's actually an animal. And it has this long stalk that would attach to the ocean floor, and then it would have sort of these flowery pieces that would branch out from it. There's another little one here that you can kind of see how it would branch out. So that's probably why it was called a sea lily. But it was an animal. So if you're ever walking along Lake Michigan, look for rocks that are really round and look like beads. They'll probably have a little hole in the middle. That's a piece of a crinoid. And we're really lucky at the museum to have a whole crinoid fossil here, most of a crinoid fossil here, so you can really see what the animal looked like. Another cool thing about this fossil is there's some other little fossils around it. There's this brachiopod here, and I'm going to show you some more of those from our collection. Looks like there's another piece of the crinoid here. And even if you look really closely, I think there's an impression of a leaf here. It's really hard to see though. Lots of information in this piece of rock about a bunch of different fossils. And here are some smaller crinoids we have in our collection. So you can kind of see what they would look like outside of the rock if you saw the whole round part. Here we have a few different examples of corals that would have been in that sea. These numbers that are painted on them, these are called accession numbers. That's just how we keep track of stuff in a museum. It doesn't really say anything about the fossil itself. But this one here is something called a compound coral. This is sort of a single coral cup fossilized from a coral colony. And corals are actually an animal as well, rather than a plant. We actually still have corals in the ocean today. If you've heard of the Great Barrier Reef or any coral reef down along like in the Atlantic Ocean, those are the same relatives of these corals. These are like their ancient ancestors. Here we have another colonized coral. This one's really gotten smoothed out, so it probably had a lot of water running over it at one time. You can see that pattern. So these are patterns you can look for when you're looking for fossils in your driveway. And then finally we have a horn coral. So while these corals would typically form colonies, meaning a whole bunch of these animals would live all in one place, horn corals were solitary, which means they lived alone instead of with a big group. But here are two examples of the horn coral. Obviously, they look like horns. But this is one type of animal that lived in that really ancient sea that used to cover Indiana. The last fossil I'm going to show you out here is a brachiopod. And if you remember when we were looking at our driveway fossils, we actually had a lot that looked like this. We had a lot of brachiopod fossils. They're really one of the most common fossils you're going to find in Indiana. We have another one here attached to our crinoid fossil so you can get a better idea of the shape. So here we have a mold fossil. Here we have the cast of that mold, the cast fossil. So two different kinds of brachiopods. Again, the most common fossil you're going to find here. So very likely you'll find some brachiopods in your driveway. This was another animal that lived in that shallow saltwater sea. They kind of look like clams, but they are a different species. They're a different kind of animal. And there are still some brachiopods today, but they're not as common as clams and mollusks and stuff like that. There's one kind of fossil you're not going to see in our museum collection. That's a dinosaur fossil. It's possible dinosaurs did live in Indiana. It's likely they lived in Indiana, but the layer of sedimentary rock that you would have found their fossils in has been eroded away. Throughout the Ice Age, as the glaciers passed back and forth, it scraped that rock layer away, so we don't have any evidence of dinosaurs living in So unfortunately, we don't have any dinosaur fossils in our collection. But these fossils are even older than those, and still pretty cool to find and look at and see what kind of life lived in Indiana a long, long time ago. One more fossil I wanted to show you in the museum was this mastodon leg bone. This is from the lower part of the leg of the mastodon. The mastodon was an Ice Age mammal. It was here until about 8,000 to 10,000 years ago when it went extinct, but it looked like an elephant with covered in brown fur. We also had woolly mammoths in this area. They just weren't as common, but woolly mammoths and mastodons look similar to each other. Woolly mammoths are a little bit bigger. They have different tusks and different teeth. This is actually on loan to us from the Porter County Museum. They have the rest of it there, but this mastodon fossil was found in Porter County, so we know that they lived here at one time. Here at the museum, we have some plants in our gardens that are considered living fossils because they've been around on the earth such a long time. One of them is right behind me. This is a ginkgo tree. Ginkgos first appeared as fossils about 270 million years ago, and they've remained relatively unchanged. So this type of tree is very, very old. And we have a couple more I'm going to show you too. Behind me are two more living fossils we have here in our gardens at the museum. These are magnolia trees, and they first appeared in the fossil record about 25 to 95 million years ago. It's not quite as old as the ginkgo, but still pretty old. These plants actually came into existence before bees did, which means unlike a lot of plants we have today, which are pollinated by bees, these, when they first appeared, were probably pollinated by beetles. We talked about pollination this summer and how it's how bugs help plants reproduce and make more flowers and more plants. Here's the last living fossil I'm going to show you in our gardens, and these are ferns. Ferns first appeared in the fossil record about 360 million years ago. So a long, long time ago, even older than the magnolia trees that they're next to right now. But another really ancient plant that still exists today. If you want to learn even more about fossils, I'm going to include some resources at the end of this video. Also, you can look up books at your local library, and you can find other resources online. You can also call the museum and set up a time to see some of our fossils up close. So thank you all so much for joining me today. I hope you learned a lot, and I hope you had fun.